Welcome back, and thank you for tuning in for this video. In the previous video, I went over the basics of chemical nomenclature using the IUPAC system. I didn't really go over any of the rules. I just went over the vocabulary involved. We're going to go through the rules. I'm not going to give you all of the step-by-step, like list out all the rules. What I've done is I have created this flow chart that shows you how to go through it. So if you follow this flow chart, you will follow the IUPAC rules for pretty much any compound that you're going to be given in a basic chemistry class. And so if you are sitting in my class, if you're one of my students, then you have this flow chart given to you. If you're watching this on YouTube, I will put a link in the description below to access this PDF, or you could pause the video, take a screenshot, and have it for you. Once I actually get into it, you might not be able to read it on the screen. So go ahead and pause the video, take a screenshot, and look at it. But you'll notice that I have just a series of yes or no questions that lead you and tell you what to do whenever you answer them. So we're going to go through this, doing some examples. I'm going to do just name to formula right now. So we're going to take the chemical name and go to the chemical formula. So the first example is barium nitride. So when you look at our flow chart, the first thing here says, does the name contain any Greek prefixes? So remember, those Greek prefixes, they're not necessarily always Greek, but make sure you notice this part. If the prefix is part of the name of a polyatomic ion, then our answer is no. So you need to recognize those polyatomic ions. And I have for you here a list of these polyatomic ions that I'll be referring to throughout this video. So if it's one of those like dichromate or biphosphate or something, they have prefixes, you would ignore those and answer no to this question. So this one, we have barium nitride. Does it contain any Greek prefixes? Well, no, it does not. So I answer no. Now the next question, does the name contain the word acid? Well, no. Does the name contain any Roman numerals? So I don't see any Roman numerals. So no. So now it tells me what to do. We're going to write the symbol and charge of the cation. The cation is always the first one listed. In IUPAC nomenclature, we always list the positive one first. So the cation is first. Well, barium has the symbol of Ba, and barium is in group 2 on the periodic table. All right, it's over here in group 2 on the periodic table. So it has a charge of +2. So I have written the symbol and charge of the cation. Now I'm going to write the symbol and charge of the anion. All right, so nitride is going to be an element. All right, since I answered no to this first question, or well, not necessarily, but since I am right here, nitride is from nitrogen. So I'm going to write N, and nitrogen is here in group 15, so it has a -3 charge. So I've written the symbol and charge of both the cation and the anion. So now the next step, it tells me, is to cross the charges, which means the number of the charge of the cation becomes the subscript of the anion and vice versa. Now it's just the number. We're going to ignore the plus or minus when we do this. So I'm going to take this 3 and bring it down here. And I'm going to take this 2 and bring it down here. And so now I have Ba3 in 2. So I have crossed the charges. That's what I mean from now on when I say cross the charges. That's what that means. If your cation's charge is more than 1 and the anion is a polyatomic ion, well, that's not the case here, so we'll come back to that. And then the last step here is reduce the subscripts if possible, which means can this and this both be divided by the same thing? It's just like getting the least common denominator in math. So or reducing your fraction. 3 and 2 cannot both be divided by the same thing, so this is already reduced. So barium nitride symbol is Ba3 in 2. That is our final chemical formula, and our flowchart tells us we're done after we have done that. So that is our first example, and that's how it works. So let's do another example. Okay, so let's get rid of all of this, and calcium oxide. So I'm going to go through the flowchart again, just starting over. So does the name contain any Greek prefixes? No. Does the name contain the word acid? I don't see the word acid there, so no. Does the name contain any Roman numerals? Nope. So I'm going to do the same thing. I'm going to write the symbol and charge of calcium. It's in group 2 also. And then I'm going to write the symbol and charge of the anion. Well, oxide obviously comes from oxygen, so that's O, and oxygen has a -2 charge. So now I'm going to cross the charges. So I'm going to take the number of this one and bring it down here, and take the number here and bring it down there. All right, so I've crossed the charges. So now I have Ca2O2. And then the last step is to reduce the subscripts if possible. Well, 2 and 2 can both be divided by 2. So they're actually going to reduce to 1. And we don't actually write the 1. So our symbol is then simply just CaO. And that is the formula for calcium oxide. And so following the IUPAC rules, this is what you get. Again, this flowchart helps you without having to make you memorize the rules. If you go through the flowchart every single time that you work one of these, eventually, if you have this flowchart in front of you, eventually you're not going to need the flowchart, and you'll be able to do it without it the more you practice it. So I'm going to go through the flowchart every single time just so you get the point. All right? So, chromium 3 chloride. Let's start again. Does the name have any prefixes? No. Does the name have the word acid? No. Does the name contain any Roman numerals? Yes, it does. So I follow the yes arrow, and this just tells me the Roman numeral tells us the charge of the cation. Okay? So that is not telling me to do anything, it's just giving me information. So I know the charge of chromium is +3. So when I write the symbol and charge of the cation, I'm going to write the symbol of chromium, and it's a +3. The Roman numeral is telling me that it's +3 because chromium is one of those transition metals that has multiple charges. So in this case, it's a +3. And then chlor is chlorine. All right, so that's right here, it's Cl. And its charge is -1 because it's in group 17, and that's the charge of group 17. So then I'm going to do the next step here is to cross the charges. So I take my 1 and I bring it down here, and I take my 3 and I bring it down here, and that leaves me with CrCl3. Again, we don't write the 1 as a subscript. We just leave it there because the fact that we have chromium tells me there's at least 1 chromium there. I don't need to write the 1 to tell me there's 1 chromium. If there wasn't any chromium, then I wouldn't have Cr. So the fact that Cr is there tells me there's at least 1 chromium. So there's no reason to write the 1. So we never write the 1. Okay, so this is our formula for chromium 3 oxide. Moving on, let's do some more examples. This may get a little tedious, but it gets the point across. So now we have potassium phosphate. All right, potassium phosphate. Does the name have any prefixes? No. Does it say acid? No. Does the name contain any Roman numerals? No. So potassium is K, and it has a charge of +1 because it's in group 1. Okay. Now I'm going to write the symbol in charge of the anion. Well, anion is phosphate, and this is what you need to recognize. If it ends with ATE, then that means it is one of these polyatomic ions. If it ends with ATE or ITE, it's definitely one of these. There are a few of these polyatomic ions that do not end with ATE or ITE. I mean, notice most of them it's 8, 8, 8, 8, 8, 8, 8, 8, 8. You have a couple of IDE ones, and you just need to recognize those by their names. So phosphate is right here. Phosphate is PO4 minus 3. Okay, so the symbol for phosphate is PO4 minus 3 is its charge. So what you need to recognize is that PO4 is its symbol. This is the symbol of phosphate. So when I say write the symbol and charge of the anion, you write the whole thing. And then when I cross the charges, I'm going to come down like this. Now, I do want you to recognize that right here it says, if your cation's charge is more than 1 and your anion is a polyatomic ion, well, my anion is a polyatomic ion, but my cation's charge is not more than 1. So I don't really have to worry about that right now. We will do one in a minute where you do. All right, so I'm crossing my charges. And so I have a 3 here and a 1 there, but we don't write the 1. So now I just have K3PO4. So this is the formula for potassium phosphate. And notice the subscript out here is a 1. I didn't write it. This is part of the symbol. All right, so 3 and 1 don't reduce. So that is my final formula. All right, so let's do another example. Lead 4 sulfite. All right, so this is the Roman numeral 4. ITE tells me it's a polyatomic ion. So I have, does the name contain prefixes? No. Does it have the acid? No. Does it have a Roman numeral? Yes. So that's the charge. So lead's charge is 4. So I'm going to write the symbol and charge. Well, lead symbol is Pb, and its charge here is plus 4. All right, and then I'm going to write the symbol and charge of sulfite. Well, I need to look over at my polyatomic ion. Since it ends with ITE, I know it is a polyatomic ion. So sulfite is right here, SO3 with a -2 charge. All right, so I'm going to write SO3, and it has a -2 charge. This is where this next part comes in. If your cation's charge is more than 1, 4 is definitely more than 1, and our anion is a polyatomic ion, sulfite is a polyatomic ion, then I need to put my polyatomic ion in parentheses. So I'm actually going to put parentheses around my polyatomic ion. And then when I cross the charges, my 4 comes down here outside the parentheses, and my 2 comes over here. So now I have Pb2 parentheses SO4, or sorry, that's SO3 because it's sulfite. SO3 and then a 4 on the outside. So now my last step here is to reduce the subscripts if possible. Well, I'm only talking about these two. This 3 is part of the symbol for sulfite, so we do not change that. It's part of the symbol. That's why we put it in parentheses to separate it. So 2 and 4 can be reduced. So I'm going to divide them both by 2. That becomes a 1. This becomes a 2. So my final formula is Pb, keep the parentheses, SO3, 2. There is my final formula for lead 4 sulfite. All right. So for our next example, we're going to do copper phosphate. All right. So let's look back at our thing. Does the name contain any Greek prefixes? No. Does the name contain the word acid? No. Does the name contain Roman numerals? Yes. Roman numerals tell us the charge of the cation. So I write the symbol and charge of the cation. All right. Copper is Cu. Its charge is +2 because that's what my Roman numeral tells me. I'm going to write the symbol and charge of the anion. We've already looked up phosphate in a previous problem, so that's PO4 minus 3. All right. Now my cation's charge is more than 1, so I'm going to put my polyatomic ion in parentheses, and then I'm going to cross my charges, and I have a 3 down here, and the 2 comes down here. So that gives me a symbol or formula of Cu3 parentheses PO4 2. These subscripts do not reduce, so this is my final formula. All right, so we've done a whole bunch of ionic compounds. We're going to keep going with some more examples, and this time we're going to get to something that's not an ionic compound. We have hydronitric acid. So does the name contain any prefixes? No. And if you're not sure, look down here on the flow chart. These are the prefixes: mono, di, tri, tetra, penta, hecta, hepta, octa, nona, deca. If it's not one of those, your answer is no. All right. Does the name contain the word acid? Ooh, yes, it does. Yay! So does the name start with hydro? Hydro, yes, it does. So I'm going to write H plus 1, because if it's an acid, the cation is hydrogen. So I'm going to write H plus 1, and then I write the symbol and charge for the element, very important, the element represented by the rest of the name. If it's an element, that means I'm not looking at the polyatomic ion list. So the rest of the name, nitric, which element could that possibly be? Well, that would be nitrogen. So I'm going to write the symbol and charge, oops, that's a negative, symbol and charge of nitrogen. Okay, and now I'm going to cross the charges just like I have been doing. So I'm going to cross the charges, and I get the 3 there and the 1 there. And again, we don't write the 1. So my final formula is H3N. And then I am done. I would reduce if possible. That can't be reduced. So that is hydronitric acid. So I followed the flow chart again. Okay, let's do another example. This time we have carbonic acid. Does the name contain any prefixes? No. Does it have acid? Ooh, yes it does. So does the name contain the word hydro? No. So I'm going to go this box. Write H plus. Again, it is an acid, so hydrogen is the cation. So I have H plus 1. Now, if the acid name ends with ic, then if the acid name ends with ic, then use the 8 form of the polyatomic ion and write the symbol and charge. So this is carbonic. So, oops, went backwards. So this is carbonic. So I'm going to look at my polyatomic ion list, and I find carbonic is the 8 form. So ic becomes the 8, so it's carbonate. So CO3 is my symbol, and the charge is -2. So it's CO3 -2. So then I'm going to, as my flow chart here tells me, I am now going to cross the charges. So I'm going to take my 2, and it comes over here. My 1 comes over here, and I don't write the 1 in my final formula. So I have H2CO3. This is carbonic acid. Notice when I have a polyatomic ion, the name does not say hydro. It just says carbonic. Hydro is how we distinguish something as a binary acid versus an oxyacid. Oxyacids are going to have the oxyanion and hydrogen, and binary acids are going to have an element and hydrogen. So go back and look at those definitions on the previous video. All right, so let's look at another example of nomenclature. We have phosphorous acid. So does the name contain any Greek prefixes? No. Does it contain the word acid? Yes. Does it start with hydro? No. So it doesn't start with hydro, so I know that it's going to be a polyatomic ion. So I'm going to go ahead and pull up my polyatomic ion list, and this time it's phosphorus. Okay, so I'm going to be looking for that. Now this says if the name ends with OUS or us, then use the ite form of the polyatomic ion. So when I look at my polyatomic ion list, I'm going to be looking for phosphite. So you just change the OUS to ite. Now, on this one, you would change the OUS to ite, and it would say phosphorite, but that's not one of the polyatomic ions. It's phosphite. Phosphite and sulfite, the phosphorus ones and the sulfur polyatomic ions, the names get changed a little bit. You'll get used to it after a while. But phosphite is PO3 with a -3 charge. So let's write that. We have PO3 with a -3 charge. And then we're going to cross the charges. And again, it's just the numbers, all right? So that gives us H3PO3. Now, when it says reduce if possible, a lot of people want to reduce these because you see two threes. But again, this 3 is part of the phosphite symbol. You do not change the symbols ever of the polyatomic ions. So the subscript for it is out here. It's that invisible 1 that we didn't write down. So make sure you remember that. So there is our formula for phosphorous acid. Okay. Just a few more examples. Carbon tetrachloride. All right. So this time, does it have any prefixes? Well, tetra is one of these prefixes. So yes, we finally answered yes to this question. And notice there's only one box here. If you ever answer yes to this question, there's only one place to go. We're going to write the symbol of the first element with the subscript. All right. So you're going to write the symbol of the first element with its subscript that's given by its prefix. If there is no prefix, then there is no subscript. So that means carbon, we simply write the symbol for carbon, which is a C. We are then going to write the symbol of the second element with a subscript that is given by the prefix. So tetra is 4, and the element here is chlorine. So that's the element, chlor. All right, so I write Cl, and the subscript is given by the prefix 4. Carbon, 4 chlorine. That's what carbon tetrachloride means. Carbon and 4 chlorines. So CCl4. That's it. These are the easy ones. Notice this does not say anything about crossing charges or crossing anything. It doesn't say anything about reducing anything either. You simply write that down and you're done. All right, so for these, you should be able to recognize that that was a binary covalent compound. They're the easy ones. All right, Dinitrogen Tetroxide. Okay, so let's look at that again. Does it have any prefixes? Well, it has di and tetra, so yes. So I write the name of the, or symbol of the first element, which that is nitrogen. And the di means 2. All right, and then I'm going to write the symbol of the second element. Well, tetra is the prefix, so ox is the root of the name, and so we have oxygen, and tetra means 4, so N2O4. A lot of people are going to be inclined and have the idea that because you've been doing all those ionic ones that you're going to reduce those. But you'll notice, follow the flow chart. It does not say to reduce ever. You just write that down. So dinitrogen tetroxide means you have 2 nitrogens, 4 oxygen. That's what it actually means. So that's what it is. This is the final formula for that one. Okay. So let's do one last example, Diphosphorus Pentoxide. Okay, so does it have any prefixes? Yes. So we're going to write the symbol. Phosphorus is a P, di is 2. All right, and again, oxide would be OX, so oxygen, and pent is 5. So P2O5, diphosphorus pentoxide. Now I want you to notice that, yes, penta is the prefix, but I didn't write the A, and that's because we're attaching it to oxygen. So when your prefix ends with A and the element name starts with a vowel like O or A, then we're not going to write it. a second time. So we just dropped the A. So it's pentoxide instead of pentaoxide, just because pentaoxide sounds weird. So pentoxide is easier to say. And that's why that was left off there. We'll get into that more in the next video when we get into the examples from going from formula to name. Okay. So that's it for our video today for our examples. Hopefully that made sense to you and you were able to follow along. And thank you for watching. Have a day.